Hey everyone, you're listening to the Simple Electronics Podcast. I'm your host, Dan from the Simple Electronics YouTube channel, and this episode is brought to you by PCBWay. More about them a little bit later on. How's everyone doing? I will apologize right off the bat for maybe some intense rambling on this podcast. The simple truth is it was like 40 degrees Celsius, whatever that is in Fahrenheit. Let me see, 40 C2F. 104 degrees Fahrenheit today, and I worked outside all day, and that made me come home and kind of relax in the air conditioning. It is now 9:40 p.m., the day that I'm supposed to release this to my Patreons. So yeah, you're going to have to be a little patient with me on this one. So what have I been up to? Well, for the first part, I have been making videos. Over the last couple of weeks, I've released 3 new videos, and I want to talk about them, 4 actually, and I want to talk about them here with you guys. So first and foremost is the tiny USB-C charging boards. I don't know if you've seen these, or if you've seen the video. I'm going to link to it in the description. I do know that some of you are only audio listeners and do not partake in the YouTube channel. So for those people, I will describe what I did. So I have found these new lithium battery charger boards on Aliexpress. In fact, Aliexpress sort of recommended them to me. This is a rare case of the algorithm doing good stuff instead of the usual horrible stuff that it does. Essentially, it is a board like a TP4056 board, one of those single cell lithium ion or lithium polymer charger boards, except it has preset current to be a little bit low. I don't remember how much it was, 600 milliamps, I think, instead of the typical TP4056 boards, which are like 1 amp. So this one's good for either trickle charging bigger cells or sort of using smaller cells. And it is the entire size of a USB-C female receptacle. So essentially, if you can imagine the metal tip of your USB-C cable, that is the size of the board. In fact, the board is a little bit smaller than that. So this is a tiny, tiny board, perfect for embedded devices. It was very inexpensive. I think they were like under $1 a piece, or probably around $1 a piece. And that is Kazakhstan kopecks, so Canadian dollars, which aren't worth that much these days. And these boards are incredible. The fact that they are very small. The only thing that I really, actually, there's a couple downsides, but the one big thing that I really wish it had was a protection circuit. So for those of you that don't know, you can get a TP4056 board, which has, just that chip itself on board. But you can also get them for a little bit more, like literally pennies more, like 5% more cost with a DW01 chip integrated. And so what the TP4056 does, essentially it takes your 5 volts in from your USB connection, and it will drop that down to a constant current, constant voltage charging setup for a lithium battery. So essentially it will give you, usually they give you about an amp, and it ramps up the voltage, as you charge, and then it'll top off at 4.2 volts and then hold that 4.2 volts constantly while the current ramps down for the cell that is charging. That's all it does. That means that if you draw too much current from the lithium polymer battery, you can potentially damage it. If you over discharge it, you can potentially damage it. If you overcharge it, you can potentially damage it. Now, this board, the TP4056, the chip, it will not overcharge it. However, if you have other components in your system, let's say a DC motor can actually charge a cell or a battery because when it freewheels, it'll act like a generator. Or a solar panel is another good example. A solar panel can easily overcharge a lithium cell. And so when you pay the extra little bit to get the DW01 chip, what that chip does is it makes sure that your cell never overcharges, never over discharges. That means, it'll cut off the cell from your project at about 2.75 volts or something. They're usually set quite low, but still they're there. And on this board, the tiny little one that I did a video on, there is no DW01. I don't know if you'd be able to fit it on the same board, but I feel like we're probably in a space and time where lithium cells are in everything. And I think it should be just about time for a manufacturer to come up with an all-in-one sort of TP4056 and DW01 combination IC. It'd be really useful to have protection and charging built into the same IC. Now, I'm sure this exists, but what I mean is a ubiquitous one that we can get on a Chinese product, a place like Aliexpress or something, for very little. The TP4056 by itself is like incredibly cheap, as is the DW01 in volume. I'm going to check right now. TP4056, 100 pieces. Let's see how much I can get. Let's see. So the TP4056 for 100 of them is $6 Canadian. That's just about like $3.50, $4, probably $4 American. So that's for 100 of them. So that means they're about 4 cents each. And let's check DW01, 100 pieces. They are about, they're $3.50 Canadian. So about half the cost of the TP4056. You add a couple of resistors, couple of capacitors, couple of LEDs, and, Bob's your uncle. You can make hundreds of these boards, including the PCBs, for like $20, like literally hundreds. So that's crazy. So what I want to see is a combination IC with those two in it, which is very inexpensive. Like, I think if you can make a very small packaged TP4056 with protection built in for a single cell and have it be like 10 cents each in volume, maybe even like 5 cents each because you're saving on the package costs, that would be an incredible IC. And I think all my projects would have lithium batteries at that point. I'd at least have to, build my own circuit board and play with that. If you guys know the part number of something that suits these needs, let me know, because I would like to order a whole bunch and check them out. Next video I did was the flashing lights video. Does your microcontroller work? Essentially, that was a PCBWay sponsored video. Thank you for the sponsorship, PCBWay, by the way, where I essentially designed a PCB that has 15 sort of pins. It's got 30 resistors and 30 LEDs, and you use it to plug into your microcontroller to test to see if all the pins are functioning, all the inputs and outputs, or I should say just outputs, are functioning. So this was a really fun project to make, and in fact the viewership is kind of good, which is odd. It was a very simple board to design, sort of. Actually, no, this one was kind of simple. I did do another board, which we'll talk about later, which was a lot more complicated. However, this used parts that I had in stock here. And the problem with parts that I have in stock here is that I wanted to go smaller than what I had. So essentially, my goal was to use 0603 components, which, by the way, I hand soldered. I hand soldered every single component on this board. So that was 30 LEDs and 30 resistors. However, I didn't have matching 0603 resistors to go with the 0603 LEDs. So I ended up using 0603 LEDs and 0805 resistors. So the passive components that you don't see, that don't light up, that don't do anything, are essentially far larger than the active components, the ones that actually light up. So that was interesting. Really cool if you were watching my live stream. I put them all together, and in the end, I think one board we had a couple of LEDs that weren't working at all. And so it was fun to go back and sort of reflow them. I tried really hard to, resolder them. It didn't work. And then I just removed the LED, put the LED back on. Then we noticed that a few of the LEDs weren't sitting quite flat. It's very difficult to solder 0603 LEDs by hand already. But what made things a lot worse is that I was doing this on a live stream. So I had to solder about 30 centimeters with my face about 30 centimeters away from the LED. I was not using any magnification. I mean, I did use my soldering visor for one of them. I think I built 3 boards, but in the end, some of them were crooked. And so what I did is I just flooded a whole bunch of flux on top of the board, put it on my hot plate and reflowed it like that. And it went really well. And so I, set it down, reflowed it. A whole bunch of the LEDs fell back into perfect alignment. The solder joints looked really good. And then I removed the board from my hot plate with a pair of tweezers, set it down on a silicone mat to cool down. And then since I watch Joey Does Tech, I think it's Joey Does Tech at JDT. I think so. He repairs mostly Nintendo Switches, PlayStation 5s, Xboxes, and very recently graphics cards. Well, when he does repairs, let's say he swaps a charging port out on a device, what he'll do is he'll let the solder solidify, but before the board goes completely cold, he goes back in and cleans all the flux. So I have this board sitting on the silicone mat, and I'm like, okay, it's probably cold enough. I grab a rag to take the, all the flux off, because this is going to be under the camera, right? And my first swipe with it picks up like half the LEDs and resistors, maybe not half, maybe a quarter of the LEDs and the resistors, just rips them right off the board. And so I have a cloth now that's filled with these microscopic components, which now aren't oriented in the proper orientation, by the way, because LEDs are polarized. You sort of have to set them all to the right polarization, to the right direction. And then it's just like, oh, this is why it takes me so long to make videos. So it was fun in the end, but I had to restart, do another board. So I think I built 4 boards, 3 of which function because the other one is in a Ziploc, all of its parts. One day I'll repair it, but yeah, that was my big frustration there on that one. But the video got almost 1,100 views, which is pretty decent for a simple board like that. Usually the very simple projects, which I find, by the way, the most useful projects and the projects that people like you at home are more likely to want to replicate to get your own, because I think it's useful to have these kinds of things on hand. They typically get much lower views, but this one was pretty decent. Somehow my audience kind of jived with it. And I don't know if you watch the videos at all, but I have started at the end of my video, after my traditional thanks for watching and the video fading out to black, I now fade back in and put in a blooper or, I don't know, some sort of extra content. And at the very top, I thank my Patreon patrons, because it means a lot to me that they are signed up to my Patreon. And I also thank my live stream viewers, because again, it's much less soul crushing to make YouTube videos when you have someone doing the work with you, or at least keeping you company while you're doing the work. I started YouTube to sort of like scratch the teaching itch a little bit. But the other thing is the sense of community. And I really get that during the live stream. So yeah, thank you to my Patreons and to my live stream viewers. Next video I thought was going to get a lot more attention than it did, but it just sort of came out like a wet fart. I ordered 4 microcontroller boards direct from Arduino, and I unboxed them, used the Arduino IDE, and give them a try. And all of this is based on the Arduino Uno R4. And in fact, I'll let you guys, the people, or you folks, I guess I got about 5 to 10% women listening. Hey there, girls. I decided to get the Arduino Uno R4 from Arduino because I noticed that online on Aliexpress, same as you can get the Arduino R3 clones, you can get the R4 and the R4 Minima clones. However, you can purchase them with the Arduino silk screening. So you are literally purchasing a fake, like you're purchasing a counterfeit product, which is really not cool. I believe the Arduino Foundation there, or I don't know if they're a foundation, the Arduino company, their stance on the selling of clones is that it's totally fine. You can call it a Arduino Uno R3 compatible board. You're allowed to do that. But the things like trying to sell it with their logo, with their branding, with their reputation behind it, that was never cool. And the fact that these Chinese companies are now doing that so brazenly, before it used to be sort of like tongue in cheek, you could find them, but they didn't like show up at the top of the results. But I challenge you, go on AliExpress and type in Uno R4. I'm going to do it right now. Uno R4, and you'll probably find them with the silk screen. And let me see, that's R3, R4. These are the originals. Wow, these, maybe they cut down on it. Oh, I'm taking up a listing here. So I can see that they photoshopped out some of the silk screening. I don't know if that means that the silk screen is not there, or if that just means that, it's going to be sort of not, it'll be there, but just it's photoshopped in order for you to buy it. But no, here we go. No, I found a listing. So yeah, you can buy the R4 Minima, or you can buy the R4 Minima with logo and cable. So that is sketchy. I think that is not cool. Mind you, I bought the R4 with logo, the Minima and the Wi-Fi one. I bought them because I want to make a video sort of comparing the legit one to the counterfeit one. And I want to warn people that if they want to buy these things, they should buy them. That's fine. Arduino is completely fine with that, but not the ones with the Arduino logo. That is where you draw the line. Now, between me and you, we know, right? Me and you, we understand that if we buy one of those, we are not going to be selling it to someone under the pretense of it being an Arduino product, right? We would just buy it for curiosity or whatever. And I guess the damage from that is kind of low. It's like intellectual property laws, meh. Like it's not it's not right. It's not correct. It's not doesn't have good karma attached. I don't know how to explain this, but at least we're not defrauding anyone. It is essentially the Chinese company that is defrauding Arduino, and we're supporting that. So that's not, it's not good, but at least it's not as bad as, someone like me or you buying 100 of these and going out and selling them as legitimate items. We're not doing that. Still, I would strongly recommend that you do not buy the clone that has the Arduino logo. So I'm not going to link it in the description. I know I can get some affiliate money. In fact, let's see. Oh no, I can't even get affiliate money for that one. So it's not as much of a moral quandary, but I would not have linked it, and I will not link it on the video I make of this. I will link the clones, which are very obviously clones, but not the ones with the sort of like the Arduino branding on them. By the way, if you're getting a Minima, I would actually, even if you're getting the Wi-Fi one, I would just get a clone. I think the reason why my video fell so flat, I mean, aside from regular stuff, is that the R4 is kind of not exciting. It's really not exciting. So it is now like I don't remember what the microcontroller is, but it's like, it's nothing really special. Oh, there you go. Yeah, it's a Renesas RA4M1, which is like kind of disappointing when you compare it to, let's say, a RP2040. It has 48 megahertz. Okay, big whoop. 4 UARTs, 1 CAN. CAN is good, but RP2040 has CAN as well. 1 SPI, 1 I2C, and 14 analog inputs. So that's good. It's nothing bad. But then you've got 256K of flash, which is not a lot. You got 32K of RAM. That's fine. And then the worst part is, in order to get Wi-Fi, they add an ESP32S3, which in a way I'm wondering, why aren't we just using the S3? What's the whole point of this Renesas chip? I don't quite get it. I do know. Okay, ESP32S3 is not the end all be all, but there are ESP32 chips that'll crush these Renesas chips. And in fact, RP2040, I mean, hello, 2350, hello, like, I don't know. I feel like it's kind of a wet fart. It's not that interesting. The R4 is not interesting enough. The other thing that video taught me is that Arduino is no longer as beginner friendly as they used to be. It used to be you open the IDE and you select your board, and then you get examples that match that board. Well, I first of all had to update my installation, even though my installation of Arduino comes from after the R4 was released. I had to update it before I could even find the R4 in there. Fine. That's fine. But then even worse is that it doesn't distinguish between the Wi-Fi and the Minima version. And so when I select very specifically the Arduino Uno R4 Minima, it still allows me to upload all of the examples that use an LED matrix, which is on the Wi-Fi board. That doesn't make sense to me, because let's say the only board I got was this Minima, right? Like maybe I don't know about the Wi-Fi. Maybe I'm taking a course in high school, or maybe this was a gift from my parents. So I go on the website, download the IDE, select the Minima, upload the Game of Life, and on my Minima, and it does nothing. It doesn't work because it doesn't have the LED matrix that the Wi-Fi has. So why not? What's the point of selecting the Wi-Fi or the Minima if I can take the Wi-Fi code, the examples specifically for the Wi-Fi, and put them on the Minima? Why doesn't the IDE gray those out? It's a bit strange. Another reason, by the way, you probably want a clone is because, yet again, the Arduino only comes with the female pin headers. They don't have holes, they don't have holes to add your own row of male pin headers, which is a bit weird. The other thing is that, like, between the R4 Wi-Fi and the R4 Minima, stuff like the power on LED is in a different spot. Like, wouldn't you want to make your design internally consistent? I mean, they still use the barrel jack, both of them. They also moved away from the FTDI chip, which is very interesting. They are using a Atmel chip to do the USB to serial. But yeah, stuff is in a different spot. And with the Minima, which you don't save a lot of money, by the way, you don't get the LED matrix, which I'm sort of fine with, and you don't get the Wi-Fi, again, sort of fine with. There are some like ESPs like to just have Wi-Fi built in, so whatever. But the other thing is you don't save a lot of money. The Minima, I don't remember the exact numbers, but I think it's only 20% cheaper than the Wi-Fi, which is not cheap also. Like, I don't know. The other thing is apparently, and this I'm not sure, I'd have to look back up, but I think someone in the comments of my video went and said that the current handling capabilities of the Renesas chip that's on the R4 can only handle sourcing or syncing like 2 milliamps. 2 milliamps? Really? I mean, this is something that is geared towards beginners, right? And sometimes beginners, they light an LED and they think that's super cool. Let me see if I can plug this motor in, these tiny little motors. Let me see if I can plug that in and get that going. And I have done that on my Uno R3. I have not killed my chip. Are we going to kill the chip on the R4? Well, let me tell you, once I'm done my video warning about clones and clones and counterfeits and comparing the two, I'm going to try to drive. Like, I'm going to try to pull like 10 milliamps. I'm going to try to pull 20 milliamps. We'll see if we damage the Renesas chip. And if we damage it, that's going to be another video of me sourcing another chip, seeing how much the raw cost is for the chip, and reinstalling it on the board and installing the bootloader, because I think people will be frying these things because of the low current capability. I am doubtful that Arduino is really the same company that it used to be when it released the Uno R3. I think it needs to move and shake with the times a little bit. I'd be curious, did they sponsor open source? Because if they sponsored open source, I think there's something left to them. They're still fighting, and they're still very maker centered. If they didn't sponsor open source, then I don't know what their priorities are, and maybe I'd like to know.
Just a quick interruption to talk about this episode's sponsor, PCBWay. PCBWay has been a long-term sponsor of the channel, and I think they're a good match for my channel because they provide quality PCBs for a reasonable price. You can get boards manufactured up to 100 mils by 100 mils for just $5, including shipping to Canada, $15 US, including shipping to USA, $12 US, which is incredibly cheap for professionally manufactured PCBs. I can personally attest to the quality of these PCBs, and so if you want a circuit immortalized forever, check out PCBWay.com with the link in the description. Now back to the conversation.
And the last recent video that I posted is about those little AA and coin cell testers. I bought 2 of them on Aliexpress, both by the Aneng brand, Aneng, A-N-E-N-G, I think. Yeah, A-N-E-N-G, yeah. Aneng, right, whatever. That brand. 2 different kinds, one that looks better than the other. And that video totally bombed. People are just not into it. 350 views, very low. Not that the video took me that much effort to make. It was a fairly low effort video to make. It was just essentially testing and teardown of those 2 devices. However, the 2 devices gave very different voltages depending on which one was used. So if you don't know, it's just a little device with a voltmeter built in, and it has a small resistor built in. And what you do is you either clamp the cell or touch the cell to two contacts on the device. The voltmeter turns on. There's a little bit of a resistor inside of the device, pulls a small current from your cell, and then tells you if your cell is good or not by reading the voltage. One of them has a chart on the back to tell you, if you read this voltage, then your cell is good, getting weak or dead. And so they're very simple devices. There's not much. I felt like I did a decent job making a video on this one because I took them all the way apart and I put them underneath the microscope. So I had captured video from the microscope. I had, circuit analysis, kind of, sort of. I did kind of like above and beyond. I even used the really fancy Unity gear, like the 5.5 digit multimeter, to test out what the actual voltage should be while testing. And yeah, that video is not being appreciated. So I think what I'm going to have to do with that one, if I wasn't busy recording a podcast at the moment, spoiler alert, you're listening to it, I think I will change the thumbnail on that one and see if it gets a little bit more, attention, because I think on the technical side, that video is pretty good, but it is less entertaining. I guess it's really hard to get a really bad electrical shock from a battery or a cell tester, right? However, I don't think the video is a failure. People liked it because for the 350 views it got, which is nothing, it got 11 comments. So it got a lot of engagement. Like, people are talking about it, which is pretty neat. So maybe you should go take a look at that video if you haven't seen it and tell me what you think. It's possible it's just a very boring subject, right? But I did do my due diligence. Like, I did it more complete than I would have otherwise. While I'm on the subject of those Unity test suite of tools that I got, 5.5 digit multimeter, the power supply, the oscilloscope, there's 2 function gens, and thermal camera. So those things I'm very grateful for. The interesting thing is the way my filming setup is. I believe I showed it on a Patreon only video a long time ago, but essentially my workbench, the surface that you guys watch, where my cutting mat is that I film on, is a very common workbench around here, sold by Canadian Tire. I believe you can probably get something very similar at Harbor Freight, but it's essentially, it has a bottom shelf made out of like black MDF, like black with a melamine coating, a black melamine coating. And then you've got 2 drawers and the work surface, black melamine. Then on the back side is, it has like a pegboard, and then it has a shelf, a very small, like in length shelf above that. And that's where I have my video filming lights, which is awesome because now that I think about it, none of them are burnt out and they're on like all the time. So I've got those lights, but then I have a 2x4 going across the front, anchored into the wall to the right and to the wall to the left. And that is where I hook my camera to. That 2x4 is slightly higher than the height of the workbench. And the reason for that is that I needed to go a little bit further from my work surface with my camera. So, and it's decoupled from my work surface. So I can shake my bench and my camera doesn't shake, which is kind of the goal here. I didn't want it to shake. Well, when I put my test gear up there on that upper shelf, because the 2x4 would have blocked the controls to the bottommost piece of test gear, which happens to be my power supply, I had to raise it up a bit. And the only thing I had on hand was an empty box of 3D printer filament. These are fairly sturdy boxes. They're not really that big. They have sturdy cardboard. And so I put that down, and then I put the power supply on top, which weighs somewhere around like 30 pounds. I don't remember how much exactly. And then on top of that is the multimeter, and then on top of that is a function gen. So while I was live streaming last week or the week before, I was just going, on my merry way, probably working on the LED microcontroller tester. No, another PCBWay project, which we're going to talk about very shortly. And while I was soldering on this thing, there's a crash. I got hit in the head, and my webcam I was live streaming just gets knocked off the mount and starts dangling. I'm like, what the hell is going on? So here I am, hearing a noise, got hit in the head. My webcam is dangling by the USB-C cable. I will put the link in the description if you want to go see that moment, and subscribe to the live stream channel while you're there, please. I beg of you. But what had happened was the equipment stack actually crushed the filament box and tilted the whole stack forward, which had a whole bunch of little component boxes on them, which then slid down, hit me in the noggin because my equipment stack is like almost to the ceiling. And then off my noggin, hit my webcam. And the new webcam I use to stream on is the Insta360 something or other, the webcam one, something 2C. It has a magnetic mount. It is not attached by a threaded connection like you would think. It doesn't have a quarter 20 on it. It's a magnetic mount. And so it knocks it off. And so I'm like, what the heck just happened? My viewers are like, sort of like trying to understand what happened too. But yeah, so just to let you know, don't trust the structural stability of a filament box, at least not long term. So in the high heat of a few days ago, we've been in a heat wave here in Ottawa for a couple of weeks now, but it's been really intense the last week and a half or so. I cut up some pieces of 2x3 and a little bit of plywood. It made myself a support, but if you want to go see that funny moment, it's linked down in the description. But I do recommend that you come to the live streams because then you can interact. You can have input on how the stuff goes together. You can have input on what scenes I shoot and stuff. I make polls. So yeah, maybe I'm shilling the live stream a little bit, but I have to say it's a lot of fun and it's more fun with more of you there. So yeah, I'd love to see you there. I don't have a constant schedule at the moment because my work schedule is extremely variable. Also applied for work, which I presume I may have gotten a phone call from this potential new employer yesterday, but I missed the call. Called back, number doesn't work. So because it's like one of those huge companies, like very, very big companies, they might have, outgoing only lines. And I think that's what that was. So waiting patiently to see if I get a new job. But the best way to do it is to go onto my channel, youtube.com/SE streams altogether, not the altogether part. And sign up for alerts, like put on the little bell. Typically, I will try to post, the night before I stream. So that's probably the best way to find me. All right, so I might as well bring up, since the podcast is almost done, what I've been doing on the live stream and what you're going to be expecting from future live streams and also future videos that are coming out. So I went through a huge saga trying to get some PCBs to work. Now, not my PCBs. I bought these from Aliexpress. I bought some USB PD triggers, essentially PCBs that make your USB-C charger output higher voltage than 5 volts and, however much current. These boards were a little bit expensive, but they are the top of the line. I think they go up to 48 volts possibly, and a couple amps of current. I think they're 240 watt. Anyways, regardless, I've got that all figured out. It took quite a while to get it working, but I did get him working. So the video on that will be coming very soon. And also we assembled a PCB for the next PCBWay video. Just looking at the date, it's the 13th. So I have about 10 days to make this video. So I'm going to have to work on it pretty shortly. But what it is a Formula One start-stop light. And I'll tell you, this board, I've talked about the project before, but maybe you don't listen to every podcast. This board was incredibly difficult to route. There was a lot of components on it, some SMD, some through-hole. The assembly is a little tedious because there is an order of operations. Some parts are on, let's call it face A, through-hole, and there's parts on face B, like the microcontroller, that will block access to those components' legs. There's also SMD resistors that go underneath the microcontroller. So it's kind of a chore to put together. And I thought the final product would look pretty good. Problem is, I kind of got screwed a little bit. I didn't look up the maximum current output for the RP2040. It's not as bad as the Arduino Uno R4, but it's adjustable. So what it is I think you get 5 milliamps maximum. I'm not sure what the default is. What is the default setting? Just asking AI here. 4 milliamps. So yes, they're trying to output 4 milliamps at 3.3 volts, which means that my green LEDs are very dim. The other thing is I ordered I ordered the PCBs, and I completely forgot to order LEDs. So I don't have a matching set of green, yellow, and red LEDs. So I have green LEDs in frosted, so like the whole body is green. I have red LEDs in frosted, so the whole body is red. I've got green and red LEDs in clear, so the whole the body is clear, but they shine red, but not enough of the red not enough of the green to do the whole board. And so no matter what, I have to have some LEDs that the body is, colored, and some of them that the body is transparent. So that doesn't look very good. So what I did is I ordered some LEDs, and now I'm finding that my green LEDs are not bright enough at 3.3 volts. I mean, no matter how small, I guess what the deal is I'm going to try to set the GPIO to much higher current. So from default, the drive strength is 4 milliamps, and you can set them up to 12. So hopefully bringing up the drive current to 12 is going to be helpful, because every pin has to drive 4 LEDs, at least for the green and the yellow. For the red, it only has to drive 2 LEDs, because for some reason I put pairs of red LEDs on separate pins. Now, why didn't I do that for every LED? Don't ask me. But the point is, I should be able to overcome the brightness issues. We're going to see. I have to assemble one more PCB. So the first one was sort of like a trial run to make sure I can get it working. Next, I'll have to do it with the new LEDs. I ordered all new LEDs. I ordered enough of the body colored ones to make a full matching set. And I also ordered whatever I was missing of the clear body ones to make a matching set. So I literally have like 600 LEDs coming. I ordered a set of 100 of all the missing colors. Let me see if I can tell you what I ordered. Oh, and I ordered some extra ones too. Great. All right. So I got some orange body colored ones. I got some pink body colored ones. Some white yellow. Now, white yellow, the image looks like it's yellow, but I hope white yellow doesn't mean warm white. But regardless, we'll see. So transparent body yellow ones, transparent body red ones, transparent body green ones. So those are all the ones I didn't have. And then the yellow bodied yellow ones, transparent bodied pink ones, because I do have some viewers that watch BitLooney streams and they come over to my stream and they assume I'm going to have the same sort of pink LEDs. So, when I make a test board and I'm, letting people choose the color, it's nice to have them be able to choose pink. And then I have transparent orange. So these are a whole bunch of LEDs that I'll have to, try out, make sure they work, see what colors they look like, see the relative brightnesses, and hopefully get the PCB working. So that was that. I also had to re-up on resistors. So what did I order here? I had to order 470 ohm and 220 ohm resistors. Fun fact, I wanted to buy, these are 0805s to refill my standard values. Just for those of you that don't know, I keep, I buy the kits of 0805 and 0603 resistors, but the issue is you only get like 10 or 20 of each value. So what I did is, as a favor to myself, I ordered 100 of the 1 ohm, 4.7, 10, 47, 56. So 56 is a common value I use. 100 ohms, 150 ohms, 220, 470, 1K, 4.7K, 10K, 47K, 100K, 470K, 1 meg, 10 meg, and 4.7 meg ohms. And so essentially it's like the tens scale and then the fives in between. So, 1 ohm, 10 ohm, and then in between would be 5 ohms, but I got 4.7 because it's a much more common value. So I ordered them in 100 off quantities of each one, except it seems like the 100 ohm, 1K, 4.7, 10K, 100K, I got more than that, more than 100. I don't know. These little component things are pretty full with resistors. So when I went to order new ones now, because I used a whole bunch of the 470 ohm resistors, and I used a bunch of the 220 ohm resistors on projects just now, so they're running a little bit low. I noticed that the price difference for getting 100 and 500 was like negligible. I guess because in today's day and age, because of the shipping crisis and, energy crises and whatever crises we're dealing with these days, it's just not economical to ship over 100 of a single value SMD resistor. So I think this is a really good price, but for the 470 ohm and the 220 ohm, I paid with coupons just about $3 Canadian for 500 of them. So if you're going to be sending parts over, you might as well get a larger reel, and that means that I won't have to re-up for quite a long time. Now, it does get really expensive because all the values that I've told you, let me just count these up. 1, 2, 3 times 1, 2, 3, 4, 5, 6. That's 18 values, right? If I were to do this again in 0603, which I really do want, I want at least 100 of each of those values for 0603. At $3 a pop, it becomes very expensive. So 0603 resistor, I'll go 500 pieces, see what it's worth. It's probably going to be it's $3 a pop per value. So 18 times 3, we're looking at $60 in resistors, but that's a lot more resistors than I need. But the other thing is, if you get a variety pack, again, you only get like 10 or 20 of each value. I really wish I could just pick and choose my own value pack, so I can get 50 of each. Because when you do a project that uses, like, for example, my Microcontroller Tester PCB, that one used 30 LEDs, which means one board used 30 resistors. And I built, 4 boards altogether? So already that's 120 resistors. Thankfully, I only did 60 of each, right? Because it was one value times 15 and one value times 15 per board. So my packs of 100 were working out. And that's why I need to re-up, is because I used more than half of my stash. But now at 500, I'll be good. But those individual packs of 20 each of each value, that's not good enough. I would only be able to build one board of with each value, which means that if I would have screwed up like I told you I did with the hot plate and pulling the components off, I would be screwed. I would have to salvage them from from the rag that I used to wipe off in order to get my video done. So you see where I'm sitting here. It's a little bit weird. If I want to get resistors in, I would have to do an investment of like $60 for resistors. Yes, I would have a lifetime supply, because that $60 would give me 500 of each resistor. But the point is, it's still $60 right in one shot. So that's kind of like my conundrum. I can also buy them locally, but 500 of them would cost $5. So it'd be more. Yes, I can buy fewer, but also then I have to pay for shipping. There are some services like Mouser. It's free shipping, but I have to spend $100. Let me just check how much like a 0603. Let's go like 220 ohm resistor. Let's see what that costs. So size, in stock, sort by price. Let me see here. So here is, if I buy a reel, right, of 5,000, then that means that I'm paying $0.001, so a tenth of a cent. But that times, that's 5,000 of one value, and so that's $5. So yeah, that's a lot, but it's $5. There's a reel, that's a reel, that's a reel. Oh boy, I don't know if I'm gonna get to buy individuals, because all the cheapest prices are sold on the reel. There's a reel of 50,000 for 2.6 cents each. That's a lot of money. I don't need that many at all. Is there? Okay, here. The cheapest resistor, so it's 0603. It is 14.5 cents each. Yeah, I can't do that. But if I want to order 100, it's 2.5 cents each. So even if I would buy 100, it's $2.50. I'm way better off buying 500 for a couple cents more. And I don't have to pay the, taxes, sales taxes on that. And I don't have to buy $100 worth of stuff in order to get them in for free shipping, because shipping is probably going to be like $25 if I don't get free shipping. So yeah, a little ridiculous when you think about it. Yes, I can get it far cheaper, to make my whole package, but I end up with far fewer resistors. And honestly, I'd rather overbuy a little bit and, get it internationally, shipped to the door. And then on top of that, I can use them forever. Like when I die, my wife is going to have to give away my resistors to a makerspace or something. Or I don't know. Maybe I'll find a use for them. Maybe I'll make a 1,000 resistor divider to make a sort of potentiometer of sorts. Who knows what the future holds? But I do know that this is the end of this podcast because it is now 11 p.m. and I still need to edit this and I still need to get to bed. So I want to thank you all for listening to this podcast. Most of it a little bit ranty. And again, it's because my energy is low because the day has sapped me of all my energy. I'll catch you guys on the next one. Thanks for listening.